All right. Hey, everyone. Welcome to the Konveyor community call for October 17th, 2024. My name is Dylan Murray. I'll be the host today. Um, Again, friendly reminder, please just add your name to the attendee list if you're here. I've pinned the agenda in the chat. Um, First things first, as always, is there anyone new that would like to introduce themselves? Uh, Give you an opportunity now. At least say hi. Okay. Cool. So then moving on, I wanted to just before we get into our usual demo and roadmap space, um, because we haven't met for a few weeks, I want to just provide a little bit of a update, kind of where the Konveyor community is focusing, as well as just provide just a, set the stage for kind of what we're going to be showing off here for the milestone review. Um, so I've included a link to some slides in case you're totally unfamiliar with Kai, which is Konveyor AI. It's our attempt to take all of the work that we've done to improve the Konveyor analysis engine. What we're trying to basically do is take the analysis output and source that as RAG data to use within generative AI. So I guess I can just quickly show off this slide to kind of give you a little quick picture as kind of what you're about to see in what we're demoing. Before, we've obviously had source code. You run the analysis, and that generates that fires a bunch of rule violations that gives a bunch of extra data about how to go fix what's wrong to migrate to your desired technology. What we're doing is we're taking that output as well as other data that's sourced from the Konveyor hub and presenting it to an LLM and having the LLM generate updated source code with some basic set of reasoning as to why we're going to make that change. On top of that, we're using agents in this approach that's also called Reactive Code Planner, which you'll see in a minute. That is basically allowing the LLM to iterate upon itself and fix its mistakes to get us into a much better spot after everything is done. So again, this slides are a little, I think they're made in August, but a lot of good details there if you're totally unfamiliar with what I'm talking about. With that said, what we've been trying to do is focus on getting Kai into a spot where it is ready for what we consider like a tech preview release, or version 0.1, if you will. So to do that, we've had to make, we've basically broken it down into 3 milestones. I'll show you the board in a minute as when we get into milestone 2, but we've just completed milestone 1. And milestone 1 was really focused on exploring the agentic approach that I was just showing you a second ago, as well as attempting to take our existing IDE experience and really improve it, give it a lot of love, figure out how it could be rethought to support something that allows more code fixing than just servicing the analysis results. So I tried to structure these demos in order that I think will build a larger picture if you're coming to this with fresh set of eyes. The first thing that we wanted to do actually came before our focus on Kai, but it's still relevant to our mission here, which is that for Konveyor 0.3 to 0.5, we reworked the CLI tool to use a container runtime. After much back and forth, we kind of learned that this wasn't necessarily the approach that we wanted to stick with. Having a containerless version specifically for Java is incredibly beneficial, not just to us, but to our users as well. So Emily has been spending the last few weeks taking the enhancement that we presented the last community call and implementing a containerless version of Java analysis within Contra. So let's start there. That's going to be the most familiar, I think, to outside of the car world. Emily, would you like to go first?
Yep, sure. I can go ahead and share my screen. Okay. So before I actually show the containerless Contra running analysis on a Java app, I wanted to show this very quickly. First, this is the original iteration of Contra running analysis on a Java app. So this does require a container runtime, and I just wanted to show the time difference for one between the two versions of Contra. So on the left is Contra, on the right is the output of the analysis log, and then the bottom we're just watching the containers that are created. We have the analysis container and the Java provider container, and it basically does this for, as you can see, nearly 9 minutes. I'm just going to skip to the end so everyone can see that it took 8 minutes and 57 seconds, and that was, I'm sorry, I should have said this at the beginning, that was the Cool Store app I wanted to analyze because I know that is used a lot, especially in testing Kai. So,
and Emily,
just,
that's all of the rules, right?
Yes, that's all of our default rule sets that come packaged with Contra. I recorded this on 2 separate videos because I thought to do this after I recorded the first one. So give me 1 second and then I will show the container list version running of analysis of the same application. So again, at the bottom, you should be able to see that we are not creating any containers. The right side will have the analysis logs, and the left will be the logs from Contra. I'll skip a little bit. Oh, okay, so that took, so you can see, 33 seconds compared to the containerized version that took 9 minutes. So I think that is a huge difference just in, excuse me, performance alone. Yes, those are from the rule sets repository. And then we can just see our output here. So excuse me, everything works as usual. And that is it for that. Does anyone have any questions? Pranav, did you?
I was just as surprised as you, Pranav.
Yeah.
Maybe we can explain why.
Yeah.
How come it's so much faster?
I know at least on Mac there was a lot of performance issues with Podman. I think a lot of file I/O processes and things like that slowed it down, and we did find ways to speed it up. So if that's another disclaimer, I am on Mac right now, so if I was on Linux, it probably would have been quicker. Or maybe if I was using Docker. So there are things that could change the total time for the containerized version.
I can also mention on Linux, I noticed that, and this is my guess, I'm definitely not an expert on this. I think that because JVM works by like essentially assigning thresholds of what it can use on the host, and I'm basically giving it the entire resources of the host, and Podman doesn't necessarily always do that. So I think it was more constrained in how much memory and CPU it could actually use. I can tell you, if I ran this like totally unabated, it got up to like 900% CPU on my machine, but it finished in like 25 seconds, which was cool. So I'm sure there's probably some constraints we want to set on that. But
I think this also goes to show how much the things we do with dependencies cause this runtime to be 10 minutes in the first place, because in the container, you're not using a Maven cache, as opposed to that. Once you, when you run it on your machine once and you get some of the dependencies cached, the subsequent runs are going to be a lot faster than the first one.
Yeah, that makes sense.
No, it does not. But just to be clear, what we're showing off here, there's no containers in the second flow. But that's awesome. Thank you, Emily.
Yep.
Any questions? Okay. Moving on. So again, I'm trying to present this in a little bit of order, so hopefully this helps make sense. We're going to hand this over to a consortium of people here, but essentially this is the work that we are trying to enable some form of like repo level awareness to be able to go and make changes upon the code repository based on the suggestions of the LLM. What I did link to, and then I'll hand it over to you guys. This is a kind of overall design doc that explains what we are doing to accomplish this. But the demo is going to be far more interesting to look at the documentation. So who is going to take this?
So we totally planned this out beforehand, who was going to take it.
Do you want me to come back to you?
Yeah,
Okay.
let's come back to it. Yep.
All right, no worries. Sounds good. Okay, we will come back and get a demo there. Scott is out for a doctor appointment, but I wanted to highlight some of the work that he has done this sprint. So again, now that you have an idea of where we're going with Kai, we did put together a general roadmap. This roadmap is trying to define like the ideal user experience that we want to achieve, even beyond this first version of what we're trying to accomplish after milestone 3. It's really trying to rethink, considering before a lot of our focus was on the UI and hub flow that you get out of the operator install and directly using the CLI. The IDE was kind of always like this afterthought, and there wasn't a lot of visual components needed for it, right? But quite honestly, it was really just triggering the analysis, and then you get point some lines of code with a snippet. What we're trying to do is rethink how this user experience can work in the IDE to best support the Kai experience. What you'll see if you go and click this issue, you'll be presented with a nice long tree where you can try to get an idea of what we think the high level goals are to really get the UX nailed down. There's a link to some wireframes that Scott's starting, really kind of rough basis around how to configure the IDE extension, how to configure analysis. And then from there, we need to start kind of digging in this milestone of how do those analysis results actually get surfaced back to the user, and how do we walk the user through iterating upon resolving those issues. Additionally, how does that actually interact with this code plan approach? Because obviously you could have a lot of files that are modified and all that kind of stuff. So there's no demonstration here. I just wanted to call out that if you're interested in kind of learning more about what we're trying to build for the IDE experience, this is a really good kind of parent issue to go follow the breadcrumbs for. So are there any questions on that? Okay. So next, again, I wanted to reiterate, we've started from the ground up with the IDE. So if you're used to the existing Konveyor IDE extension, all that's gone. We're starting over from scratch. We've spent these past 4 weeks starting from nothing and getting to where we are today. So I'll hand this over to David or Ian, whoever wants to take this.
I'll take it, Dylan.
Awesome. Thank you.
All right. Yep. As Dylan was saying, now we have a new IDE experience. This is the view inside of the VSCode Debugger. On the right side, you'll see a panel with the walkthrough for setting up the configuration options for an analysis run. and the start analyzer now will actually start a real server that is communicating with an analyzer LSP binary, and that is currently running on inside my VS Code instance. So I'm able to kick off an analysis. Oh, it's not started, so start it up, and let's see the output here. Now we should be able to start an analysis on the configured source code base with the rules and all of the arguments that are configured there. That's kicked us back a set of results that we're able to parse through in a web view within the VS Code extension. And this web view is sort of just a POC at this point. We're able to just load up the violations and incidents and display everything that may also be displayed in the diagnostics panel here. We're sort of mirroring the diagnostics that are created in the web view and the from the results. So when you click on an incident in the web view, you're able to interact with the workspace in ways like opening the file that the violation and incident are reflected in. And in the future, we plan to add more ways to interact with these results. And this is sort of just a rudimentary implementation, and it lays the foundation for future enhancements on this stuff. So other than that, there's one other flow that's possible with our demo here. You can click through all the results and open the files automatically when you're kind of just tabbing through the results here. And that is it. There's other enhancements here, like we're using Patternfly 6, and that's just sort of reskinned everything here with the Patternfly React components. And yeah, we should be able to leverage the new Patternfly virtual assistant library that they have recently, or Patternfly folks have recently published, that may have more functionality for us to leverage in the future. And that's it.
Awesome, thank you. Any questions for Ian? I see some slides too on the actual agenda here. Is there interest in sharing that, or do you want me to share those on my screen?
Oh, sure, you can share those. Wasn't aware.
Oh yeah, I totally had ChatGPT put those together like 5 minutes ago.
Well, you want to provide
we can
context
go
about
through it really. How about I'll just share it really quick.
Sure, go for it.
Let's see. Are you able to see my pretty slideshow?
Yes.
So yeah, basically everything that Ian just demoed, we're just going to talk about it really quick. So the editor extensions, I like this tagline that ChatGPT gave me. Almost smart enough to fix your code. Just give us one more commit. So a lot of what we did in the last month was to, like Ian and Dylan said, was to rewrite the MTA or whatever plugin that exists and write it in something that we could take ownership of and could make changes to. So quick, like, why are we rewriting it? This is also made by ChatGPT, but essentially the problem that we had with the existing code base was that we didn't write it. So we had no accountability for the way it behaved. There was a lot of code that we weren't sure how it interacted with the things that were presented in the extension. And because of that, it made it difficult for us to interact with it and make changes. So what started as us playing around with the idea of getting familiar with VS Code extension writing became our path forward. A lot of that had to do with what we believe would be our greatest strength, would be our ability to write web views and create web views and leverage those to drive the user experience, where we actually have folks that know what they're doing. So we decided to pursue a route where we could lean heavily on our experience with React and Patternfly and all the cool stuff that Ian showed. A cleaner architecture, I think this is probably debatable. It's just there's less of it, so it's easier to navigate. And the same with the improved maintainability. The fact that it's all fresh and we all wrote it within the past month means that we have a pretty good idea of where stuff is and what we broke. And essentially, this is a very quick bulleted list of everything that Ian just showed. We have a cool walkthrough that looks pretty for people that would install our extension. It includes everything. It's like a plug and play, or at least that's the idea. If you were to install our extension, the binaries that you need, the rule sets, they're all in the extension for you, ready to go. We have a walkthrough that tells you how to configure sources and targets and all that cool stuff. And we can run the analysis and we can interact with the results. And we actually have a base that we can build on. So there was the demo, and then that's a totally different thing. And questions?
Awesome. Thank you. Questions on the IDE? If you have questions about where we're going next, maybe save them, because I have that for after these milestone 1 demos. I can explain a little bit what we're going to do with milestone 2 and how the UX work that we're doing is going to actually feed into this. So awesome. Thank you, Ian, and thank you, David. Next, it might make sense if I can bug someone from the agent side to go next before I let Sam do the
Absolutely.
evaluation.
Yeah, yeah, we're totally good. All right.
Cool.
So I'm gonna share my screen real fast. Says that Dylan's sharing. Okay, there we go. Did it work? Okay, cool. Is this big enough for folks? Can you guys see it? Okay.
Yes. Sure.
Yeah, cool. All right. So I want to talk a little bit today about the work that we're doing around Kai. Well, kind of where we came from real fast and then where we're headed. So where we came from was we had a endpoint on a server that was called get_reg solution that took a Java file, a list of incidents, and a reg, which is a resource augmented generation request to an LLM, where we had these solutions, we had the incidents from the analyzer, and we tried to solve the entire Java file in one LLM request, and we sent back that diff to the old VS Code extension, and that would get shown to the user as the diff to be applied. One of the things that we realized was that doing one-shots in LLMs is quite difficult. And there's been a lot of work around the idea of agentic workflows that we wanted to really tap into. So what we kind of came up with was, I don't know who on the team coined the term, maybe it was Fabian, but like a reactive code planner. So there's this paper out called Code Plan that is a really interesting read. If you are interested, ping me after and I could totally send it to you. But we kind of took ideas from that. We took ideas from other papers we've read, and we're going forward with this approach. So the idea is that we have the ability with static tools that we have, in this case, Maven, as well as Analyzer LSP, to get structured data back about what's wrong in a project. And we're going to use that structured data in a way to ask the LLM very specific questions and do it iteratively so that if a change introduces a problem, it can get fixed by a different validator, and we can iterate through the changes, fixing ourselves as we go. I think this starts to actually kind of feel like a developer is kind of developing, right? Like when I write code, I'll write the code, I'll compile it. When it starts to fail the compiler, I'll go and fix the compiler until it compiles, and then I'll run a test. And then, so you can see how this is starting to get a full loop that starts to feel a little bit like a developer. So let's talk about the architecture real fast. We have validators. Those are kind of what I was talking about, these static tools that we're able to use to get structured information about what's going wrong in the project. Right now, we have the Maven compile step, and we have the analyzer LSP step. We have a task management system. So the validators will create tasks in our system, and these tasks are taken by a specific task runner that contains one or more agents that can actually do the work of talking to the LLM. So the task runners are, in this case, Maven compiler task runner, so a generic task runner for solving Maven issues. The analyzer task runner, this is solving the analyzer rule results. Right now, it looks really similar to that RAG solution that we had before, but we're hoping to make changes here. We have a dependency task runner, which is able to actually take specific tasks and update the dependency tree for the project to resolve a class of issues. We have what we're calling the repository context manager, and this is effectively a attempt at a virtual file system that uses Git to track the changes. And so what we're doing is we're making changes to the repository and then committing it off into its own Git working directory that we own. And then once we're done and we completed everything, we actually roll everything back so that the user is back at their known good spot. So just to kind of talk through the task lifecycle, we start with the validators. Validating, we have a prioritization that we've defined. You'll see in the demo that I'm going to show in a second, but we know that there are certain structured data output that we get that are more important than others. So for instance, when Maven compiler says package does not exist, and then you see a bunch of symbols not found for that same package, you know that fixing the package first may resolve the symbols not found. So you want to do the package first. So that's kind of the idea around the prioritization, is that we kind of can tell what's important based on the structured data. And so the queuing system inside the task manager takes account of all of these prioritizations. Once the task manager runs and resolves an issue, we will rerun the validators to make sure that there are no further issues, basically. Now, if there are more issues that were introduced by that change, what we call them is child issues. And these children issues actually then get added to the front of the queue, and we're going to go through all of the children issues of that parent issue, making sure that we fully solve that one issue. So once all the tasks are completed and all the child tasks are completed, then we'll be considered done. To allow for kind of the workflow that David and Ian were talking about, we've added this idea of seeding tasks. Seeding tasks allows us to take a specific task. In this case, in my demo, it will be a specific analyzer rule violation. We'll start with that task. We set it to a known lowest priority, basically. It gets done first, And in this case, what we're going to do is we're going to only take the issues that have that lowest seeded task priority. So we'll only solve those issues and all of its children issues, and then we'll stop. And this allows us to go through the issues one by one rather than doing a whole project in one given call, which could take a long time. I think that's kind of all I wanted to get through. I'll come back and talk about some of the future enhancements, but I'm going to switch over to the demo real fast. How much time do I got, Dylan? Okay, cool. All right, so I'm going to run this demo. This is a notebook that is in the repository if you wanted to run it yourself. So I'm just going to start it up here, and I'll kind of talk through what's happening. So we are taking, we're setting everything up for the task runners, as well as the dependency agent. And here is our incident that we're working on. This is the remote EJBs are not supported in Quarkus violation. And so we go ahead and we create the analyzer rule violation, which is our task that we create. Here you can see we're creating the task manager. We're setting up the validators for the analyzer as well as Maven. We're setting up all three of the task runners. Like I said, things were in flux. We want to rename that, but we're going to go back to it. And then you'll see here that we're getting the next task of max priority of 0. So in our system, the lower the integer, the higher the priority. So in this case, 0 is the highest priority. And I'm only going to run this loop 2 times because otherwise the demo would take much too long. And so what we can see is we ran the validators. We found 147 new tasks from the analyzer validator. And we're going to execute the analyzer rule violation. And if we look over here, we can see that this is the remote EJBs are not supported specific issue. And you can see that we've selected an agent to start working on this, and this would be the analyzer task runner. So the task manager was able to find a task runner that was able to take that specific task and is going to start executing. So right now what's happening is we're actually talking to the LLM. We are asking it, hey, how would you solve this particular issue for this particular Java file? In this case, the Java file is the shipping service Java file. So we know that there's a remote EJB there, so we're using that one. Obviously, inside the system, when you have seeded task or the IDE, you know the file because you're looking at it when you ask to fix it. And so this is the boring part of the demo where the LLM is just thinking. I apologize for that. I am talking to Llama 3 70 billion instruction via the IBM inferencing is the model that I'm using. While we're waiting, is there any questions about where we're going or anything like that?
I guess, hey, here's an obvious question.
Yeah.
What are we thinking about improving performance? Is this like a limitation we're going to have with LMs, or is it is it based on model? Can you explain a little bit about, what the options are to improve the performance around this stuff?
I haven't spent a lot of time looking into performance enhancements around like the LLM and how to make us talking to it faster. I don't imagine we can do a whole heck of a lot on that side.
Is it model specific? Like, are there some models that are just significantly faster?
Yeah, it's definitely model specific. Like
Yeah.
I've done a lot of testing with the GPT 3.5 Turbo, and it's very different.
Yeah, I think, and Fabian and John, if you're on, or Jonah, correct me if I'm wrong. But the problem is the inferencing, which is basically the serving of the model. Depending on how much resources that has is what depends on how fast this goes. So depending on the model that we're using and the inferencing of that model that we're using, and how much access to, in this case, GPUs, I believe, would really determine how fast it can go. GPUs, I believe, in this use case are not just tied to training a model, they're also tied to inferencing. And so depending on how much resources that inferencing has will determine how fast it goes. And so it really depends on that. I think this is where like OpenShift AI gets really interesting as like a serving platform for your models. If you want them to go faster, you can serve your own models via OpenShift AI and do it that way. I'm a little worried that the LLM is actually just not going to work because it's never taken 6 minutes before.
That's a
Yeah, I'm wondering if it's just not going to give you a response or something.
Yeah.
Well, hang on. I have one more question, just for I
Yeah.
know the answer to this, but I think it's worthwhile to explain this. So,
Mhm.
like behind the scenes, if you have like debug mode turned on, for example, I mean,
Yes.
the LLM's writing code, right? Like it's spitting out
Correct.
code essentially at this point. And so,
Presumably, we are getting chunk results back from the LLM right now that is attempting to do things, yes,
and so
as
like
it's thinking through the problem.
even if the performance is slow, I would assume just from like a user perspective, the same way that when I use like something like Replit or Cursor, I'm okay waiting because I'm seeing all the stuff getting generated, right? So
Right.
like that's something that we'll just bake into our user experience. It's not like it's doing nothing right now. I guess
Right. Right. And I think to do that, we would have to kind of hide some of it because the response isn't going to be useful to the user necessarily. The response is parsed by our code, turned into structured data, and then we use that structured data. Yeah, it is the live demo curse. I know. We need to get that VCR thing back in, but that's okay. Man, it is. I literally
You can
just
probably
ran.
kill it. I don't think it's working.
I literally just ran it like before I got on the call, and it worked. And I ran it like multiple times last night, and it was still working. So
It's
okay.
rate limited.
I
Do you
mean,
have
maybe.
any- Do you have like the cast results from the previous times you ran it in the Python
Yeah.
notebook?
Yeah. Okay. The call was canceled. So, this is where.
Yeah, status 500.
Yeah. Yeah. So this is basically the inferencing fell down, which is not a uncommon thing. Go ahead and run this yourself. Everything should be set up. I think you have to change some of the paths in here. I probably need to change this notebook so that it's not hard-coded paths. But if you change the paths and then set this up correctly, you should be able to run this on your own machine, on your own notebook, with your own key that's probably not rate limited, and you'll be good to go. Just to give you an idea of what changes, basically the remote EJB gets removed, as well as the the ending file looks something like this, where it used to have EJB here. Now we're actually using the web service path as well, and the post method. So these are the changes, really. These paths and these posts get used, and that's what changes for the shipping service file. And then we end up getting an error that says that we don't have Jakarta web service installed as a dependency. And so we actually are able to go and add that dependency because the package isn't found. So we end up adding the Jakarta web service via that. To quickly show off some of the future enhancements that we've been working on as well to this loop, I'm going to throw it to Jonah to show some of the JSON-based, the JSON RPC-based stuff that we've been doing. I'll stop presenting now.
Yeah, awesome. And then real quick, I realized that I actually ran your demo last night and my results are still cached. So
if you want to show it off, that'd be great.
Yeah, so basically, let me stop the infinity mirror. So here we have, this is where we had the 140 whatever new tasks. It executed the task, it yielded it. I added some more logging, but then you can see it spawned a new task. That was like a new task from a validator. It ran it. I added like a crap load of logging. And then got task package does not exist error. So then it said like, okay, the package doesn't exist in the pom.xml. And then and then here was the diff at the end. So this, I was doing some more testing, so it's not, obviously this wasn't demo ready, but I just wanted to see the diff of the shipping service. And so here you can see the shipping service was updated. And then I didn't print the diff for the pom.xml, but here's the comparison, and the comparison is false. So like the file was actually updated. And if I go here, you can see I can select for compare with selected. Well, I guess it didn't, but it didn't cache that. But you can see that the comparison was false. So it did do something. I cached some of the results. I was modifying it, so obviously that this isn't like demo ready, but you can see this is what's supposed to happen. Supposedly, if the models didn't return a 500 error, so it works.
Thanks, Jonah.
Yeah.
Thank you.
I heard a question. Let me see. Oh yeah, go ahead, Pranav.
Regarding the dependency, who is providing the information what needs to be installed?
Can you elaborate more on that?
Like which dependency to install? Where is that piece of information coming from?
I think, Sean, you can answer that. Because you wrote the dependency agent, if I'm not mistaken.
Sorry. So the question is, where is that dependency coming from?
Yeah, like which dependency to install?
Yeah. So what happens is you say, like, we get the error that says this package doesn't exist, right?
Yeah.
And so we have the package name, basically. We ask the LLM, hey, here's your error. What do I need to do, basically, to update the POM to fix that error? And it will attempt to say, like, okay, here's a artifact ID, group ID that might work. And then we have a sub agent that will go and actually, if that doesn't exist inside Maven Central, the one that the LLM chose, we'll say, hey, you chose this one before. It doesn't exist. Give me another option, basically, for the same error message. And we have a sub agent that actually goes and selects that fully qualified domain name. And we wait until we get a valid response from the LLM. And by valid, I mean we actually are searching Maven Central for that artifact ID, group ID. And if we actually get that, then we call it good.
Okay.
We add that particular artifact and group to the dependency.
Yeah, I'm wondering if the LLM doesn't know about a certain dependency at all. Like, do we break or?
Yeah. At that point, basically what we do is we say, like, hey, we can't solve this dependency issue. We'll pull the task out of the system and say, like, this can't be solved right now, more or less. Because there's definitely cases where, it might be an internal dependency that they need to update or something. Those are all very real scenarios that the LLM wouldn't know about. And this goes into some of the other future enhancements around extending these supports inside the validators and task managers, and how can we make it so that these are able to work in those environments, but we haven't thought through a lot of that.
Yeah, I think that's exactly what I was getting at. I think there's a future where we have these agents integrated into our RAG thing, because
Yep.
in the hub we are going to have all of the dependencies known. So
Hopefully.
Yeah.
Yes, I agree with you. There's a world in where we can do some interesting things.
All right, solid. Pranav, did that answer your question?
yes.
Okay, awesome. So thinking about future work, so a lot of this last sprint, I worked on this thing called the JSON RPC server. So the real conundrum is, how do we have a system so that we can have multiple different front ends that use all of this nice agent work? And so the way that we determined that was, hey, we're going to have the IDEs spawn a different process and communicate with that process. And this process will handle all of this code plan, agentic workflows, et cetera. And the reason we transitioned from the previous architecture where we were communicating with the server to now this new architecture where we're spawning a process on the local machine is because each sending a bunch of confidential data over the wire to a server is probably not that grand of an idea. So we wanted to have all of the stuff happen locally. So here you can see this is the RPC server. So it's a bunch of code, whatever. But you can see here we have a route, get code plan agent solution. And basically the IDE will communicate with this route and after it's spawned, and then it'll get back results. So here I've written a really hacked together front end for an IDE just to show that multiple different tools can use it. Eventually, we're going to have a CLI tool for integration testing and whatever, and the IDE will also be able to communicate with the RPC server. So this just shows that creating different front ends for this JSON RPC server is possible. So booting it up. So here you can see just some stuff. So we're going to go ahead and start the RPC subprocess, and here you can see all of these messages are being sent over the JSON RPC communication protocol. So all of this logging, like trace log level enabled, server thread started, et cetera, that's being communicated over JSON RPC. So next, I'm going to go ahead and initialize it. So here we have a couple of different requests. So first is an initialize request. So we're going to go ahead and initialize the RPC server with a bunch of data. So I sneakily switched this out for a different chat model so that we can hopefully see some better results. And, you know, it has a bunch of different things like where the analyzer LSP is, what route path we're going to be using for the project, et cetera. So we're going to go ahead and send that request. And then you can see, OK, we sent the request to the JSON RPC process, and it's sending it back. So here you can see initialized with config, send, et cetera. And you can see there's a lot of data here, because I think the philosophy that we're going with is we want to have as much noise or as much talking coming from the JSON RPC server as possible, so that the IDE folks can then filter that with the user based on how verbose they want it to happen, so that the user actually knows that something's happening. So next, we can go ahead and load the analysis report. So this is actually the same file that Sean was migrating earlier. So here's just visualized. And this is the actual rule set, violation, and incident that he was using. So we can go ahead and populate the get code plan agent solution request. And here, this is what the IDE would be sending to this sub-process. So you can see it's got the rule set name, rule set description, violation, et cetera, all the labels, all this nice good stuff. So we can go ahead and send this over. And now this demo is like a superset of sort of what we were demonstrating earlier. So you can see we've got the seed task, the analysis engine is running. And then over here, we can actually see the Git virtual file system as it runs. So you can see here we've got this initial commit so that anything that the agents do on the file system is automatically going to be cached and, you know, we can revert back so that if the agent decides to delete the whole repository, it's not going to completely delete the whole repository. Actually, we're just going to roll it back at the end. And all of this information, again, I really want to stress, is being sent over JSON RPC. So anything that you see here, the IDE can then display or choose not to display in different ways towards the to the user. So although hopefully maybe we'll actually get a response, or maybe we won't. Hoping, praying, although it's doing an analysis. So I think this also ties into the containerless analyzer LSP stuff that Emily talked about earlier, where we're going to have better performance on this. Okay, so we can see that the agent was selected for the task. It had like, an analyzer rule violation, whatever, it selected the agent. And now we're sending a request to this LLM. It's going to give a response. It's thinking. And right now I have the chunk. There's a log option for the LLM inferencing library that we're using that can actually show each of the chunks that's coming through. So I think that might be actually very valuable, especially in circumstances like this, where you're sort of just waiting around and you don't know what's happening. So now you can see the Git virtual file system was updated with this shipping service. We've got this, the updated shipping file. I mean, it looks kind of ugly because this is meant to be a debug tool. It's not meant to actually be the full IDE, but you can see, the analyzer task runner changed the file, etc. And then I've actually been having issues running this second version of the analysis engine. It'll take like upwards of 15 minutes. So we're really thankful for that containerless version of the analyzer LSP. So I need to get that in, and then we can update it. But as you can see, all this communication is happening with the JSON RPC process. That anything that you see here will be able to be used by the IDE in displaying and interacting with the user. So yeah, question, raised hand. Yes. I heard a thing.
That was just someone trying to join the meeting. It's okay.
Oh, okay, sorry. Yeah, that's basically it. As you can see, lots of data that's going to be sent back to the IDE so that they can use it. In terms of future things, we probably want to have some, like we said, some mention of like progress of work that is being done, notifications so that we can display that back to the user. Another thing is way in the future, I don't know if we're going to be able to do this by December, but to be able to use this Git virtual file system, say, hey, this agent did this, but I don't want that to actually happen. Let's roll back. And or a much simpler version of that would be, hey, this is the result, accept, reject, or maybe have some sort of annotation that you can be like, hey, this is great, except for this, go ahead and go fix it. So that's my demo. Any questions, comments, concerns? No questions. Love no questions. All right, love it. No questions. Perfect.
That's great. Thank you, Jenna. Thank you,
Yeah.
Sean. All right, so that is definitely kind of the meat and potatoes of what you're going to start hearing me talk about next. I'll just quickly share my screen, then before I hand over to Sam, provide a little context. So great. Basically what we showed to this point, we've got a new IDE that eventually will be integrated with the agentic approach that you just saw Sean and Jonah demo. So we're at a point now where we're generating code out of analysis results automated by the LLM. How do we actually know that the results are improving or making the code repository worse in our effort to migrate to a target technology? And this was some investigation that has been going on for a few weeks now. Basically, can we use the LLM to actually help us evaluate the results? And once we do have the evaluation, what can we do with it, essentially? So I'm going to turn it over to Sam.
Okay, just 1 second to share my screen. Okay, is that visible to everybody?
Yes.
Okay, great. So what I've been working on is a tool that can be used to help us determine whether we're making forward progress as we're making changes to Kai and the prompts and the kind of reflection workflow and so on. Basically, we just want to be able to know if what we're doing is getting better results or not. And the intention is that this, or most likely something built on top of this, or maybe just something following this general approach, but could be plugged into QE and CI and give us some hopefully relatively concrete as far as what we can get out of the LLM, but relatively concrete grades for the LLM's work. And at the very least, whether we're going relatively forward or relatively backward to the changes that we're making. So the key thing here is a Python module with an evaluator and some supporting scripts here. And the evaluator is really very simple. It's just an object. It takes a Kai config and prompt vars from a request, and the LLM result that went along with that just uses LangChain to call out to the model with a special prompt and gets back a result in the form of a YAML document that it parses into this evaluation result object. And that evaluation result scores it on 6 different dimensions. Basically, how effective the changes are at solving the problems, how specifically they address the problems, like are they very tailored to the problems that were identified, or are they kind of scattershot? How well does the LLM articulate its reasoning, and how well does that reasoning match the actual changes that it made? And how well does it adhere to best practices just in general for the language and the frameworks that are involved? And it gives pretty good results for these. The other 2 dimensions that it'll give results on are whether or not it thinks it's valid code and whether or not it thinks it's made any unnecessary changes. It usually is convinced that nothing unnecessary has been changed and all code is valid, but it doesn't really have enough context to determine that. And that might be a place we can look for extension in the future. So the prompt is just putting it into the persona of a senior engineer that is overseeing the migration of a big enterprise app, and it's farmed out its work to an AI assistant and it's going to evaluate it in that context. This prompt seems to work pretty well. I have noticed that there are some issues with this YAML report card. Llama 3 70 billion instruct does not seem to be able to consistently produce multi-line YAML strings without it breaking. Claude Sonnet is a little bit better, but I think the prompt needs a little bit of tweaking to get it more consistent. So the supporting scripts, so that evaluator can be imported, but probably the easiest way to use it is in the context of the supporting scripts here. So the one script here, run Kai, what this is there's the run demo script from the Kai repository. I just changed this to be able to take an arbitrary path to any analysis and any repository. Am I not? I think I'm supposed to be sharing my screen. Am I not?
Yeah, I think that's a good thing, Jonah, right?
I will be showing something like slightly more interesting than just my GitHub screen in like a second. So this just runs Kai against an analysis report. This parse Kai logs. This what this is doing, and actually O1 wrote this. We've got this helpful tracing that Kai does. It creates this, when you run Kai with tracing turned on, it creates this really detailed hierarchy of logs that indicate, what the prompt request was, the response that came back, the timing, all that sort of stuff. I gave this entire document to O1 and asked it to write a script that could correlate the prompts with the results and stick it all back into a YAML document for me. And it came up with this, which worked great the first time, and I had to do nothing to it. So what this does specifically is it takes the path to the Kai log directory, and it spits back a unified YAML document that's everything from the logs that it found. And then the evaluate.py script will takes that and it runs it through the prompt that I mentioned. Now I'm not going to run that because I'm having performance problems. I don't know if I'm rate limited or what, but it's taking me like 15-20 minutes to run it. I have a result already, which I can show for you. So just to show something on the screen happening here, here's it parsing the logs. As you can see, it is able to go through there and find all the LLM requests and the corresponding results. And it's going to spit that out into a document with all the Kai fixes together. If I was to run evaluate, it takes just a path to the Kai config, just so we know we're using the same model, that document and an output file. And what we can do with that afterwards is so that file is a detailed, that it outputs is a detailed YAML document with all the report cards for all the files. And let me see if I can expand this out so it's a little bit easier to see. So it gives we've got the file here. We've got its scores that it gives. Now, Llama 3 is convinced that everything is great. It gives stuff consistently very high scores. And I don't know honestly whether this is how well that this matches reality. I noticed that Claude, and I did experiment with using 01. They're more critical, although they still make mistakes. Unsurprisingly, if you run the evaluation and then you create a prompt to have it reevaluate its own evaluation, it notices problems that with its own grade, where criticisms it said don't make sense or it missed things. But that kind of multi-shot thing I think we've come to expect. So that gives us this gives us scores as well as its reasoning about why it made the decisions that it did while grading. Llama 3 is not great at explaining its reasoning. Claude is a lot better. But again, that may be just down to prompting. So finally, there's one last command here, which is generate report, which just puts out a CSV document saying the files and its scores, so that we can feed that into some other kind of tool and get a general overview. So one thing this is doing, it's calculating at the very end here an average across all those scores. It ignores the Boolean fields. I'm sure we could come up with a way to include that in the scoring. In this case, the average is just across the 4 different dimensions that it gives a numerical value to. So the hope here is that we could plug this basic framework into QE somewhere and just get a grade and know whether or not, like I said, changes to Kai are getting us better results in the view of at least in the view of the LLM or not. So not anything super thrilling to look at here, but it's all documented in that repository. Hopefully it's pretty clear. I'll make sure that the link is in the notes for this meeting. Any questions?
That's awesome. Thank you, Sam. Yeah, I think this will become clear with our next topic, kind of how valuable this tool, dumping it all into CSV data as much as David wants to make fun of it, is going to be incredibly useful. So I'm going to turn it over now to a general update on automation and testing. Before I do, I just want to provide a little context as well, as always. So one thing that we've kind of been passing over, but we really wanted to seed into our test structure, is how the Konveyor hub data is going to be also used as part of the retrieval augmented generation to improve our results. In order to do that, you got to imagine a system where you've got a Konveyor instance that has a ton of history, right? So the fact that I could correlate one application's 20 analysis runs over a period of 6 months all of that data is incredibly useful to mine to provide Kai with additional context to get better results. So in order to do that, Alex explored a script that can basically give us one of these conveyor instances out of the box to use to start exploring with that system with RAG. So Alex, I'll turn it over to you. It's okay.
Okay, so I will share my screen. I know we are on a schedule, so I will be real quick, I promise. Okay, here we go. Okay, so yeah, in order to simulate this history of meaningful data, I put together a real simple script. It's in Bash. So basically, what this script does, it just picks randomly an application from a list of 5 or 6 applications that have 2 branches, at least 2 branches. And the first branch of this application contains a very basic code with some issues that are found and reported by Konveyor. Then what it does is...
Are you able to zoom in just a little bit?
Yeah, sure, sorry. Okay.
Great. Awesome, thank you.
Okay, so basically the script creates an application based on the code from those repositories and then analyze this application. Then once the analysis completes, it changes the branch to simulate this meaningful change. So we move to a branch where some of these issues have been fixed, and then we analyze the application again. So this way we simulate these real and meaningful code changes that can be used later for Kai. So in order to use it, we just have to provide the URL to the hub and the number of applications we want to create. In this case, I'm running a Minikube, so I won't be able to wait until the analysis are complete. But basically, it creates the application right on the hub and start the analysis on them. Then once they are complete, it changes the branch, as I said, and run the analysis again. Basically, that's it.
That's awesome. Thank you, Alejandro.
Sure.
Are there any questions? Again, this is something we haven't really shown off this milestone, but if you've worked with Kai before, the entire solved incident server or the API that you would get, this is all critical data in order to actually make that API useful, which is really cool. So, any questions? Okay. Next, I'm going to turn over to Shweta, just quickly explaining, obviously, in order for us to provide meaningful testing, we need infrastructure, some type of test infrastructure, which includes, installing machines, getting VSCode installed, and eventually Kai installed. So Shweta, I'll turn over to you.
Okay, thank you. I will share my screen. Can you see my screen?
Yes.
So we have created this repo called Kai CI, and we have started doing some initial commits over here. I will show it in VS Code. So the first thing that we did is we wrote a provisioner runner .yaml. It is written by the DevOps team. We have a Windows VM now. The GitHub Actions can launch a Windows VM in the AWS, and we can use it for our testing. We have not been able to test this yet, but the provisioner is ready. Then we came out with the page object model. So we have pages, we have tests, we have environment variables that we'll be using for automation. So we are using 2 environment variables so far, the path to launch VS Code and the VSIX file to install the plugin. So I can give you a quick demo to what the test has been doing so far. So the command is, we are using Playwright automation for this. Playwright is a open source framework developed backed by Microsoft for web automation, but we can use it for desktop automation as well. So this is a command, and I will close VS Code before this so that it can launch. It is running in debug mode so that we can see it is installing the plugin, Kai plugin. And you can see it launched the VS Code window. There's a debugger. If I click on it, it will click on the Kai window and it makes sure that the Kai Explorer is opened. And next it can close the VS Code. So this is where we are so far. It can also generate reports. Sorry. So 2 tests passed. This is the report that we have been generating so far. All 2 passed, 2 and failed, flaky, skipped, so on. So this is the work that we have done so far. We have implemented formatting in the PR checks. We have came up with the README file with the instructions to install. So the next work that we'll be doing is we'll be downloading the VSIX file, latest one from the editor extension repo, and we'll be installing it from here. And the first test case will be to git clone the Cool Store app and run end-to-end test. So we'll be making progress on that. That's all from my side. Any questions, anyone?
That's excellent. Thank you. Any questions on automation testing or in general, anything that we just showed off for milestone 1 before I get into the milestone 2 goals?
Lots of great work across the whole thing, everybody. I just want to say that.
I agree. In fact, I didn't want to be corny, but I was going to put something down here because I think it's really impressive what we've accomplished in 4 weeks. So, can you guys hear me okay? I feel like my mic might not be coming through all the way. How about that? Is that better?
Okay. Well, that's way better, yeah.
All right. Thank you to whoever just told me that. Fantastic. All right, so let's move on to high-level goals. So hopefully the picture is pretty clear, kind of where we currently stand. We're at a spot where Kai is generating like really meaningful results. It's got these agents that are able to check its results and provide some type of sanity check before we're just spitting out a bunch of garbage like you sometimes are used to with LLMs. So where do we go next? First, we want to continue to improve and iterate upon the containerless contra work. This is kind of small potatoes. Think like we were talking about restricting the JVM so that you're not exhausting your machine if you don't want it to. So some more config options, making sure that the user has more flexibility in how they can install and run the dependencies. So this is going to continue to iterate upon that for what we're releasing in Konveyor 06. Then what we want to do is truly demonstrate this value that the reactive code planner work is doing. So obviously, I think we need to improve how users can actually drive the example. So we're going to go and update the demo script to use a RPC client CLI that can actually go through the entire flow manually, as well as we need to work to integrate this into the IDE experience. Obviously, no one wants to be dealing with JSON RPC calls like you saw that data coming back in Jonah's screen. We want this all to be visually appealing and easy to follow from a user perspective. So that ties into this next work, which is you saw the IDE. We're at a spot where we're actually kicking off the analysis and we're spitting the results back, which is awesome. In one sprint, essentially, we've kind of rewrote the functionality of the existing IDE plugin. Now we can focus on getting this new functionality, which is servicing the analysis results to guide a user through accepting and rejecting code changes that were generated by the LLM. That's going to be the focus of this next sprint. Let's see. So on the automation side, I want to kind of tie these two stories together because I think this is what's going to be kind of really interesting. on how we can demonstrate value on the agentic design. What we really want to invest in from the testing automation side is some type of like nightly reporting system. That nightly reporting system is going to spin up a machine, install Kai on it, run Kai on a sample application with a specified target, and then run evaluation with what kind of Sam showed. When that evaluation runs, we want to put together just some type of report in CSV, YAML, JSON, whatever, that we can actually consume. And the idea is that hopefully every night or once a week, whenever the system runs, we can take a set of applications with a given set of models that we're interested in introspecting and saying, hey, look, over the course of this past 4 weeks, we're actually, the LLM is saying that we're generating significantly better results than we were 3 weeks ago. For this given model and this given migration path, we're getting very bad results. So what kind of agents can we implement to improve those results? I think once we have a basic CI system here, we can just throw a bunch more applications and models at it and start to gather where our weaknesses are and where our strengths are. So this is really going to tie in like 3 of our stories. And then in parallel, we didn't actually talk about this because Juanma's been doing this work and he is enjoying his lovely vacation. But we're trying to flesh out more rules to better support a Spring Boot migration. So that's going to open up a bunch more applications we can start testing as well. So if I kind of had to sum all that up, truly what's the basic goal of Milestone 2? It's getting the whole end-to-end experience fleshed out to a basic minimum happy path and proving value with some type of test system. Questions on Milestone 2? This is work that's already started as of Tuesday, Monday. And this kind of leads into open discussion, which is that if you're interested, we are working on this tech preview release Kanban board. There is a Milestone 2 tab where you can kind of see the work that's in progress. You can see the work that needs to be done if you're interested in picking something up. And this is kind of where we intend to work over the course of the next 4 weeks. This milestone is going to end on November 5th, which is going to lead into our next community call, which is 4 weeks from now on November 7th. Any questions on the milestones, the planning process, the open work? I don't see any enhancement highlight topics. I'm skipping over that, obviously. And then I just had one quick topic because I've had a few kind of questions asked me about this. And I think it's interesting to discuss. All of the work that we just showed off is not actually merged into the main branch of Kai yet. It's in a feature branch. We really want to work to get this into main. What do we need to do that? And I think these 2 things are going to be kind of obvious, but it's worth calling out in case you're trying to figure out where the heck is all this code. The first thing is the demo script will be broken. So the demo script is based on the old code base without the agent stuff. So we want to make sure that's functional. To do that, we need a client CLI tool that can actually drive that RPC server that we showed off. Specifically, let's just get it working for the Cool Store app, since that's what we've been focusing on this whole time. Once we have that in place, so a basic client CLI and the demo script updated so that the Cool Store example still works, then we intend to merge this into main. I'm hopeful that we're only like a couple days away from this. In the meantime, if you are really chomping at the bit to try this stuff out, I can show you the branch real fast. I'll stick it on that document as well. It's under this feature repository level awareness branch. Is there anything else to add to that or questions that I'm maybe forgetting to add? Okay. I'll do this. Yeah, I really want to just say thank you, everyone. I mean, I think this is really impressive what we've accomplished in 4 weeks. I think the picture is really starting to paint itself where, if I'm speaking candidly, I didn't have the full picture in my mind even 2.5 weeks ago. So I really think Milestone 2 is going to put a lot of this stuff together and paint a really, really cohesive story that I'm excited to see put together. So Great work, everyone. Is there any final thoughts or questions or comments or concerns before we end the call? Going once, going twice. Okay, I will stop the recording.